Thank you, everyone. Thank you for allowing me to speak. As you can tell, I'm not a local. I'm from Australia, South Australia. I'm the Director for Geospatial, Data Science and Analytics, which is a state government department, about 500 people, and our primary responsibility is the delivery of over 300 geospatial data sets, planning zones, cadastral parcels and valuations, administrative boundaries, bushfire, flooding, survey marks, all those sorts of foundational data sets, including address. The second part to my team is that we also deliver the digital regional plans, and hopefully if I get time we'll have a quick look at that at the end of this presentation. But we also deliver geospatial services, so across government. We are an ESRI shop, but the talk today is nothing about ESRI. So you'll see that we are trying to move away from the ESRI platform, and I'll get into why we're trying to do that shortly. It's a challenge because we have an ESRI enterprise agreement, which means whole of government statewide licensing. So why would you walk away from that and go cloud native on many open source and open platforms? I'll come to the reason behind that as well. We support our strategy, policy and forecasting teams through geospatial analytics and modelling as well. It's a small team. My team's 18 people, and that's an important number to remember when it comes to talking about why we're doing stuff and what we're doing. This talk is mainly about the geospatial data lake. Data lakes have been around for years, right? 2010. James Dixon was the first person who coined the frame. I'm not going to go into semantics of data lakes versus data lake houses versus meshes, you know, not going to go there. Think of it as a generic term. If you think of a data mart as the bottled water, cleansed and packaged, ready for easy consumption, a data lake's quite different. It's a large body of water in a more natural state where data streams in and people are free to come and take water out of the lake. Data in this instance. Right, so let's talk about why we're going cloud native, and especially when we have this ESRI enterprise agreement. And those details are confidential, but I can broadly mention a number. It's in the order of upwards of 5 million per annum for licensing, so it's a fair investment, all right? And they're 3-year terms, and then we renew. We're on our 4th enterprise agreement with ESRI, and our next renewal comes up in July next year. One of the things we're seeing is that data science and GIS are separating in the ESRI space. So we're seeing a lot more people picking up the data science and the integration of GIS into data science. When you look at the ESRI stack, it's always been a traditional, purely GIS stack. We won't walk away from the ESRI GIS desktop. We have cadastral fabric and some very specialised data structures and sets in that ESRI platform. But when we want to do our analysis, what we're finding is that the open source community is really leading the way, particularly in Python and in R, and we are seeing that we're not on that bus. So it was one of the main drivers for us thinking, well, hang on a minute, you know, what are we doing? We've got this information, we want to be able to do advanced analytics, and we're struggling to do those analytics on the ESRI tech stack. The other thing that we have done is, again, you know, it's a brave move, is we are on AWS. The rest of South Australian government is on Azure. We've been on AWS since 2016. So at the time when we went to AWS, Azure wasn't mature. So that was the sole reason for moving. We wanted to move to cloud. We wanted to divorce ourselves from having to run servers and infrastructure, and we wanted to adopt and move to cloud. So that's why we're on AWS. No other reason other than that. That's the main reason. We wanted to not manage infrastructure, we wanted to go solely serverless, and we wanted to go to cloud platform and get out of data centres. When you've got a small team, you want that team focused on the job. You don't want that team focused on patching servers, making sure that we're, you know, from a cyber security threat perspective, complicit or compliant with the latest patching and so on and so forth. So we've offloaded all of that to AWS. We use Firegate, and wherever possible, we don't run any EC2 instances at all. We use purely native services. The only EC2 instances we run are for the ESRI technology stack. Right? Now we know that ESRI is moving to Kubernetes for ArcGIS Enterprise. The vendor's own advice. it's not mature enough yet for what we are doing and where we are. So just saying, right? So we haven't gone down that pathway. So because when you start to go, and when you're on cloud, and when you start to talk to people in the open communities, what you discover is there's a whole lot of knowledge out there, and it's way, way broader than your very narrow, siloed ESRI ecosystem that we've been working in. So we've discovered a whole lot of stuff, and coming to this conference has been amazing to see the diversity of people, what they're doing and how they're doing it. There are some common threads though. Python's pretty important. ZAR 3 looks like it's pretty important. We're not in that pathway, we're using cogs. So, you know, it's an interesting thing to come here and learn this. Leveraging knowledge from the cloud and data science community is really important. Saving money. Our entire platform that we now run on AWS costs us very, very little to run. The great thing about those cloud platforms is if you are new to cloud and you're wanting to go out and try something, you can go out and try it at very, very low cost, at very, very low risk. You can then go to your executive and say, this is what we want to achieve. It's costing nothing. They're not going to say no if you're going to go and spend $200, right? You can go out there, do a demonstrator, say this is what we want to do, and seek permission, write up your business case, get your funding, and away you go. That's how we did this. We literally went and spent $100 to prove out one workload, showing the comparison on the ESRI stack to the cloud native approach on AWS, showed the economic differences, showed the performance and compute differences. You know, I had a surveyor who wanted to come and spend $40,000 Australian, so that's what, as I say, 30,000 US on a laptop to do some analysis. I didn't even think you could buy a $30,000 laptop, right? But they found some Alienware thing and they were going to go and buy it. I said, no, we're not going to do that. We're going to stand up some compute on Amazon. We're going to stand out, you know, I think we set up 768 gig of memory, 256 cores. The thing cost $20 an hour. We ran the job in 15 hours and it was done. Massive saving difference. So again, you know, cloud can save you a whole lot of money and get you better performance because you can go and dial up whatever GPU, whatever size servers you need or back-end performance you need to go and do your analytics. The other thing is, I guess, by moving to cloud and by moving to cloud native, you are able to use mainstream tooling. So I'll show you something which towards the end of this talk, our digital regional plans, where using the mainstream tooling has saved us a fortune, right? If we wanted to go out and find somebody who is skilled in ESRI Experience Builder on the ArcGIS Enterprise platform to build us a website to deliver the Adelaide Digital Adelaide Regional Plan, then those resources are rare as hen's teeth and are incredibly expensive in the market. Going out and finding a React developer, for example, there's a lot of them, and they're very, very cheap. So again, by moving away from proprietary and going out and using these open frameworks, we've discovered it's saved us a whole lot of money and, to be honest, a whole lot of grief because we've been able to go and find resources and capability locally at very, very reasonable cost. So the other driver, I guess, is that we've also getting a growing demand, I guess, driven by data scientists who don't want ESRI RESTful endpoints. They're too hard, right? So they want different ways of us to deliver them data. So the data lake's very, very good at that. So we can ingest anything, we can run it through the process, and then we can spit out any format that we want on the other side, including ESRI RESTful services if we want to, but we can do anything. So it's given us a whole lot of flexibility and opened up a whole lot of new customers, primarily in local government where they're not bound to be using ESRI technology, we're a state government, and commercial operators, survey companies and the like, who want to connect and want to consume our data. And I don't mean by exchanging data as a file, I mean like connecting and using services. Right, so this is our geospatial data lake. Who here is familiar with AWS? Yeah, a few people? Okay, so it is a standard AWS lake formation template implementation. There is nothing special about this at all. the way that it simply works is we have really three primary S3 buckets. We have a landing bucket, a raw bucket, and a curated bucket. So the landing bucket is where our information arrives. It's S3. There are folders in that S3 bucket which have different purposes, and I'm going to talk interestingly about flood modelling, which on the back of the last speaker is purely coincidental. So the data arrives in the landing bucket. It then gets ingested into raw. Once it lands in raw, there's a number of different processes, excuse me, which could be applied. So can I get a glass of water?
Yeah, sure.
Thank you. Which could be applied. So these are typically Lambda Python functions, which we run against the data, or they're AWS glue jobs. Now, this data lake's getting somewhat old. It's probably 4 years old. So there are some things we want to change, and moving away from glue is probably one of the things we'd like to do because it is fairly expensive. And broader, larger adoption of Lambda. The reason why we did glue jobs and a mixture of glue and Lambda was primarily because the Lambda execution time used to be really short, but these days you can use a lot more memory and a lot longer running processes. If they're too long, then we'll spawn off AWS batch for very long-lived processes, which might have to run for a day or two, depending on what it is. So standard stuff, the data gets pre-processed through the ingestion engine. Depending on the workflow, it will then fire off a step function through EventBridge. The processing log is maintained and updated in DynamoDB, so we can see what's happened. The glue crawlers run out and fetch data and also add petitions. The transformations are done through Glue, PySpark, and Python shell, generally wrapped in Lambda. The output is written to a curated S3 bucket and to a PostGIS database on Aurora. So even our PostGIS database is serverless. We don't maintain the PostGIS server. It is using Aurora, which if you used Aurora before, basically what you get is a admin console to the database, and that's all you can see behind the scenes. Everything else is taken care of by AWS managed services. When the processing is complete, the DynamoDB table record in the table is updated, and we then send notifications through SNS. So that's it. That's it in a very high level nutshell. Thanks. Sorry. Okay. So I'm going to talk about one pipeline and one specific data set that we load. Through COVID stimulus funding, we got $3 million to go and build out and update our very old flood studies, which were getting embarrassingly old. So we went and flew the whole of Greater Adelaide metropolitan area. And if you think of Adelaide, Adelaide's very similar to Salt Lake City. It's very sprawling, very long and narrow, bound by the ocean to the west and some ranges to the east. So population 1.1 million. It's about the same size of Greater Salt Lake City. So there's a lot of parallels. We flew the whole thing with LiDAR down to 1 centimetre resolution, vertical resolution. Got that massive amount of data and then farmed that off to a number of commercial companies to take that LiDAR and to calculate through hydraulic modelling our flood information. But not only do we have just that flood load, we have a lot of disconnected information in the Planning and Land Use Services Directorate. We have spreadsheets, we have people's shape files, everything. So we're also on a journey of trying to collate all that information into our data lake. Lots of demographic data, population growth, housing demand, land supply, that's used to support the planning decisions and the Greater Adelaide Regional Plan. Another example, lots of GIS data, a lot of it's aspatial. There's a lot of spatial data. For example, there's over 100 layers that make up the planning and development code. So flood data ingestion, like I said, there's a landing bucket. You can see that we've got these names Hark and Southfront and Stantec and Tonkin and Watertech and so on and so forth. They were the companies that we divvied up Adelaide and then handed out the jobs to commercially. We didn't go for a single vendor. We went and handed it out to a number of companies, gave them a specification that they had to return data to, and they went away and did their modelling to return the data. When the data was being returned, we had one person. We had an FTE, a geospatial analyst, ASO 7, so in salary terms that's probably between 100 and 110,000 Australian dollars per year. So times that by 0.6 to get that into US dollars. And that person was sitting there and was going to process all of those flood studies manually. And we went, no, this is not going to work. Right, this person's going to be here for years. So we sat them down and we said, can you please show us what you're doing in ArcGIS Desktop? And I don't expect you to read any of that stuff on the right-hand side, but these are the actual notes taken. There were 17 steps, so there's a couple more pages. And we went down and teased out and got the IP knowledge out of that person's brain and converted it into a Lambda function in Python within the data lake and made that process an automated process. And that's what we do now for pretty much all of our ingestion and processing through to raw to curated. Okay, when we were looking at the flood modelling and how we were going to do it, we investigated two ways of doing things. We looked at using ESRI-ArcPy, felt we were obligated to look back and see whether we could do this processing connecting to an ESRI ArcGIS Enterprise server, or whether we could do something different. We looked at things like GeoPandas, Shapely, Fiona, Raster.io and GDAL, and somebody made a comment yesterday that when you look at those sets of tooling, that a lot of them are really just GDAL in a trench coat. I like that. Somebody said that yesterday and I like that. I thought, yeah, that's exactly right. So the team that I have, we have some very good software developers, C#, they're savvy in C#, savvy in Python. So we ended up going with GDAL, even though it's a much lower level, simply so we wouldn't get bound by toolkits or frameworks getting out of date, and when updates are released, having to wait for that downstream framework to update their code. So we ended up going with GDAL in the data lake. So everything in GDAL is done in Python and GDAL within our data lake to do our transformations and processing. Not through subprocess, not calling GDAL command line. I mean Python wrappers around the GDAL libraries to run it in Python. We do build our custom GDAL library. Clearly we wanted to extend it to be able to support the ESRI file geodatabase, although that's now native. You don't have to worry about that. Adding the latest versions of GEOS and Proj required for our GDA 2020 Australian projection. Doesn't come built because not many people, I guess, are using it in Australia. We built it on an AWS Linux 2 instance. That's now an ECS container, and we stand it up, run the container, build it, kill the container. It's a Docker image. The output is about a 19.5 megabyte file. Lambda layers can be up to 250 megs, so we've got plenty of headspace. To run this as a glue job, there's a couple of other requirements to generate the wheel file. The outcomes, we got 49 studies processed, 1,744 TIFFs, many errors were discovered and had to be subsequently put through the pipeline many times. It ended up with a total of 620,000 files, 62,000 files and 640 gigabytes of data shared back to our environmental agency. So my agency is responsible for the built environment. We hand this off to the Environment and Water Department, which looks after the natural environment. That's the end result of what you're seeing. You can see that there's different categories. That's the Adelaide Airport, which is very low and under high risk of flooding. Up in the hills there's nothing, and there's a range in between. Okay, I just want to very quickly, if I can, show the Greater Adelaide Regional Plan, because that data that's in the data lake is ingested and served to the Greater Adelaide Regional Plan. It's built on React, Material UI, MapLibre, RackMapGL and DeckGL, so there's no ESRI JavaScript in this. All content and function is configured through YAML, It's able to consume ArcGIS server services, which we still have quite a number of, so we haven't migrated them across yet. Martin tile server tiles from PostGIS directly. Bespoke AWS API gateway, DuckDB, S3, GeoParquet queries directly on the database to do the equivalent of an identifier. For imagery, we're using T-Tiler and Lambda, and that's the URL there. If you put that URL in on a mobile phone, you won't see anything. You'll just get a download for a PDF. You need to be on a PC to see the full rich environment. So I'll jump out of that if I can. Drag this across the other screen. Okay. So this is what the application looks like, and I'm hoping that you can see that the complexity of this you could not achieve in Experience Builder at all. It's completely configured through a YAML file, content and maps. We have a whole lot of content, and as you scroll down, the maps will dynamically scroll and change to different scenarios. You can go and inquire on. You've got layer controls over here. You can change imagery at the base. So that's just a very, very quick look. I'll leave it there. You can explore that yourself. We're pretty proud of it. This is the first time we've ever delivered a digital plan. Every regional plan prior to this has been hard copy booklets. So keeping information up to date, allowing people to be able to zoom into a very specific area, interrogate the data, is much better than having people get a hard copy book which is out of date the moment you print it. Anyway, thank you. That's all I've got to talk about.
Thank you, Greg. Do we have questions? Yes?
Thank you for your presentation. It was very insightful. So looking at your previous tech stack, are there any specific tools or resources that you have found very hard to migrate to open source?
Yeah, look, anything which has been built in Model Builder, pretty much.
Because with ESRI, you get a lot of closed source tools, I would imagine. Yeah,
look, the Model Builder has been the most challenging. There's two things, actually. One is Model Builder, because it refers back to the ESRI ArcGIS libraries, which is difficult. But the other one is symbology. We make all of our maps in ArcGIS Pro, and then you've got a nice cartographic product, and you've then got to pick that cartographic product up and put it into Martin tile server. So we've actually written bespoke code as an ArcGIS Pro extension. So when you're on a layer or when you're on a project on a group of layers, if you right-hand click, you can export all the symbology to style files which are MapLibre, Mapbox compliant. The only gotcha is when we're using ESRI TrueType fonts, because we then have licensing issues. So we've got to go and design our own TrueType font, which is near enough to, but not ESRI's. So they're the two biggest pain points. But we are on this journey, and we're invested enough now that we're not going back.
Thank you for your talk. I was wondering, how good is AWS in handling sensitive data? Talking about the government agencies.
In Australia or in general?
No, I mean general. What's your experience in that? How does authorities feels about sensitive data going into cloud?
Yeah. So in Australia, we have very, very strict policies on data sovereignty. So, for example, we are not allowed to put Australian data into US data centres. You think maybe we would, but no, we're not. I guess maybe with the current US government, we can probably see why. Sorry. But, we're not. So the AWS data centres we have, Southeast 2, which is Sydney, and Southeast 3, which is Melbourne, and AWS sign their life away to guarantee that data will remain in that data centre and will not be shifted across to other data centres unless, of course, you allow it to be. So that is enough for the Australian government to say, okay, well, that's fine. So we use Amazon for not just state government sensitive non-public data, but we have military standards and military using these data centres with AWS, and it's acceptable as long as they're matched to a certain level of security. So cloud's not so much a problem. We're seeing a complete trend in Australia where everyone is going to cloud. South Australian government is closing its data centres. So we had 2 data centres, and we've closed one, and we're getting rid of the other as well. So we are going completely cloud. Well, maybe retaining a very, very small footprint for exchange servers and so on and so forth, where you need to have those interfaces between our state government network and direct connects out to Amazon, but it's not to be used for general workloads. So everything is going to cloud. And primarily Azure, although there's been a swing towards AWS, and the South Australian government gives you choice, so you can use Google, Amazon or Azure as your cloud centres. They don't force you to use one or the other anymore. They used to, but not anymore.
Any more questions? I have one final question. So, first of all, congratulations. I think this is it needs also a bit braveness to start this process and make a good case for migration. Can you don't have to disclose numbers, but can you give an estimate in percent how much money you actually save now from this migration?
I would say probably 80%.
80%?
Yeah, it is a massive difference. Massive difference. And that's not just all on software licensing, that's on physical servers, or it's on EC2 instances, or it's on software licensing. And including consulting companies. So if you want to go and get somebody to come and build you something on ESRI, it's very expensive because it's very, very niche. If you want to get somebody to come and build you some Python or some React, it's very, very cheap. So I'd say 80%.
Yeah, and how do you handle the change in skills needed, or maybe do you with your team? Because I understand mostly people were knew about ESRI, ArcGIS.
Yeah, look, it's been a journey, and to be quite frank, we've done several restructures. When I came to this directorate, it was very, very old, with a lot of very, very legacy systems, software, processes in place. I'm a change agent, so I came in and said, this is what we're doing. Some staff left, but new staff joined. It's okay.
Okay. Okay, great.
Sorry, one more.
One more question?
No. Follow up. So are you still going to be using desktop ESRI? Or
we will not.
Kind of like a hybrid?
Yeah, we're too invested in that.
Right, okay.
Yeah, we could not retrain all of our staff effectively. And if we did, comparing QGIS to ArcGIS Pro, there's still a way to go on QGIS to get to that level of, performance, not performance, but functionality that you see in ArcGIS Pro. Mm-hmm. So, I had to make some wins, but without alienating the entire, directorate and division. Yeah. So I conceded and said, okay, let's give this a go and see how we go from the server stack and from the web delivery and from the data storage, and let's go cloud native where we can on that. PostGIS, get away from, ESRI proprietary STE formats and so on and so forth. So we've done that. ArcGIS Pro, to its credit, works well with a lot of these open standard services and databases anyway. It's quite happy with PostGIS. So there's no issues there. And no, I will not be moving away from ArcGIS Desktop, ArcGIS Pro. We have moved from ArcGIS Desktop, ArcMap, ArcCatalog, so on and so forth. So no, we won't be doing that.
Okay. Well, no, I appreciate your talk, and I've seen other organizations do hybrid models, and I think they work very well. And yeah, thank you.
Thank you.
Any last questions? Okay, great. Thank you, Greg.
Thank you.